The journey of satellite communication began with the launch of the first artificial satellite, Sputnik 1, by the Soviet Union in 1957. This groundbreaking event marked the dawn of space exploration and opened the door to new possibilities in communication. The concept of using satellites for communication was further realized with the launch of Telstar 1 by the United States in 1962, the first satellite capable of relaying television signals, telephone calls, and data across the Atlantic Ocean. This marked the beginning of a new era where global communication would no longer be constrained by physical distance. The role of satellites in global communication in the modern world. Satellite communication is the backbone of global connectivity, enabling everything from international phone calls to live broadcasts and internet access in remote areas. But how exactly do satellites make this possible? At its core, satellite communication involves the transmission of signals from a ground station to a satellite in orbit around the Earth. The satellite then relays these signals back to another ground station, which could be on the opposite side of the planet. This process allows for instant communication over vast distances, overcoming the limitations of terrestrial communication systems, which rely on cables and radio waves that can be obstructed by physical barriers. Satellites are typically placed in one of three types of orbits: low Earth orbit, LEO, medium Earth orbit, MEO, or geostationary orbit, GEO. Each type of orbit serves different purposes. LEO satellites orbit close to the Earth's surface and are commonly used for satellite phones, GPS, and certain types of Internet services. MEO satellites are positioned between LEO and GEO, often used for navigation systems like the Global Positioning System, GPS. GEO satellites remain in a fixed position relative to the Earth's surface, making them ideal for television broadcasting and weather forecasting. The primary function of communication satellites is to act as a relay station in space, transmitting signals between distant points on Earth. This capability is crucial for various forms of communication. Television and radio broadcasting. Satellite communication allows for the global broadcast of television and radio signals. Before satellites, broadcasting was limited to the range of terrestrial transmitters, making it difficult to reach remote or geographically isolated areas. Today, satellite TV services like Dish Network provide coverage to nearly every corner of the globe, enabling viewers to access a wide range of channels and programming. International telephone calls, which once required complex and expensive undersea cable networks, are now easily facilitated by satellites. By bouncing signals between satellites and ground stations, voice communication can be transmitted over thousands of miles in real time. This is especially important for connecting remote areas where terrestrial networks are not feasible. Additionally, one of the most transformative impacts of satellite communication has been in providing internet access to remote and underserved regions. Companies like SpaceX with its Starlink project are deploying large constellations of LEO satellites to deliver high-speed internet to areas where traditional infrastructure is lacking. This has the potential to bridge the digital divide, offering educational, economic, and social opportunities to millions of people around the world. In the aftermath of natural disasters, when terrestrial communication infrastructure is often damaged or destroyed, satellites provide a critical lifeline. They enable emergency responders to coordinate relief efforts, provide real-time updates, and ensure that affected populations can communicate with the outside world. Ground stations are Earth-based facilities equipped with antennas and communication equipment to send and receive signals from satellites. They play a crucial role in controlling satellite operations and ensuring accurate signal transmission. Advances in technology have made these devices more compact, affordable, and user-friendly. While satellite communication has revolutionized global communication, it is not without challenges. The time it takes for a signal to travel from Earth to a satellite and back can cause delays, known as latency. This is particularly noticeable in GEO satellites due to their higher altitude. However, advancements in LEO satellite constellations are reducing latency, making satellite internet a viable alternative to terrestrial broadband. However, Weather conditions, such as rain or snow, can affect satellite signals, leading to potential interruptions in communication. Engineers are constantly working on improving signal resilience and reducing interference.